This video is over the velocity is a vector worksheet. So if you read here, you see that Angela and Blake are running toward each other 15 meters away. At time 0, Angela runs to the right at 5 meters per second and Blake runs to the left at 3 meters per second. So just a couple things. Angela is at 5 meters per second and then Blake is at 3 meters per second. So if I were to track their position, first off, Angela right here, we're going to call this the origin, what we call 0. And so she is going to be at a position of 0 at time equal to 0. However, Blake is all the way over here and he's at a position of 15. Now notice I'm not putting the units with here because it's already written up there, but if you want to do that, you can put the units with it. It's never wrong to do that. So then, since she is moving at 5 meters per second, then every second that passes by, she's going to gain 5 meters. And since it's to the right, she's going to add 5 meters, move to the right. So positive direction for her displacement. And then another 5 meters, and then another 5 meters. And that gives her 15 at the end of 3 seconds. For Blake, since he's moving at 3 meters per second, he's also moving to the left. So you got to keep that in mind, which means he's starting at 15, but then every second he loses, doesn't really lose, but he's moving in the negative direction for 3 meters. So this goes down to 12, and then down to 9, and then down to 6. And that's going to be his final position. So at time equal to 0, that's their initial position, and then every second after that where they end up. Next step is to graph it. So in looking at this, let's start with Angela. She starts at 0. And then at 1 second, she's going to be at 5. And then at 2 seconds, she's going to be at 10. 3 seconds, she's going to be at 15. So we go ahead and draw our straight line here. And that's going to be Angela's position. For Blake, he starts at 15. At 1 second, he's going to be at 12. At 2 seconds, he's going to be at 9. And then 3 seconds, he's going to be at 6. Now, these two lines can't look the same because if they did look the same, then they would be describing the same thing. So we're going to say that the straight line, that solid line is going to be Angela. And we'll say that we'll make the other one a dashed line. Now it's important to do this because on the AP test, you need to have some way of distinguishing between two lines where one represents Angela, the other represents Blake. Now, if you have different colors, you could do it that way, but on the AP test, they don't allow different colors. They just allow for one pencil, one writing utensil. So you have to do something creative to figure out how it's going to look. Now down here, the next one, it says the slope. Now we're looking at the slope of Angela. Angela has a rise of a run. So we're going to basically take 2 points, position 1 and position 2, and then the time for each one of those. So we're looking at the x-axis, which is going to be time, and we're looking at the y-axis, which is going to be position. So let's say at the first one's going to be 1 second, and at 1 second, she's at 5 meters. And then at 3 seconds, she's at 15 meters. So if we look at the difference on the top, that's going to be 10 over 2, and that gives us 5 meters per second, which is what her velocity was. Notice that the slope of this position versus time graph gives you velocity. Down here for part C, we're going to look at Blake. Blake, let's do the same time. So at 1 second and 3 seconds. At 1 second, Blake is at 12. And at 3 seconds, Blake is at 6. So notice we do 6 minus 12, which gives me a negative 6 over 2, and that's negative 3 meters per second. Now keep something in mind, that negative means a direction, which is what we knew in the first place where it said it was to the left. So it shouldn't be a surprise that it's going to be a negative 3 meters per second for his velocity. On the back, we're going to graph a velocity versus time graph. So on the front was position. So position it every time. But on the back, we look at velocity. Well, Angela was moving at the same velocity the whole time. So when she was starting, she was moving at 5 meters per second. After 1 second, she was still moving at 5 meters per second. At 2 seconds, she was moving at 5 meters per second. At 3 seconds, she was moving at 5 meters per second. So if I were to graph the velocity versus time graph, she has the same value the whole time, and therefore it's going to have no slope. So notice that this line right here at any given value represents the slope of this line over here. So at 0, 1, 2, and 3 seconds, the slope was 5. So velocity versus time graph is 5 at each one of those times. So that is Angela. For Blake, Blake was moving at -3 meters per second. So he's moving at -3 at 0 seconds, at 1 second, at 2 seconds, and at 3 seconds. He was moving at the same speed, same velocity the whole time. So then we're going to make this into a dashed line. And that dashed line represents Blake. All right. Lastly, the part down at the bottom here, it says that if you do a claim, evidence, and reasoning, the claim here is that the position is the same because Angela and Blake do have the same position at 9.375 meters, and that is at a time of 1.875 seconds. So that tells me the position versus time graph where the two lines cross, that represents the time when Angela and Blake are at the same position, traveling with the same velocity. Now the problem with this is at that time, they do have the same position because they cross, but at that time, they do not have the same velocity. Notice the velocity versus time graph. So let's go back to the position versus time graph first. Position versus time graph, this point right here, that is at the 1.875 seconds, and they have the same position. But if you go to the same time on the velocity versus time graph, which is right here, you can see that they don't have the same velocity because they don't the velocity lines don't cross. And that can also be seen on the position versus time graph because the slopes are different for each one of those lines. Therefore, the velocity is not the same. So the position is the same. However, I do not agree that they have the same velocity because the slope of the line is 5 meters per second, and the slope of the other line is -3 meters per second.